If you're seeking to implement LLM in your application, you're most likely going to start with two quite simplistic patterns, which in many cases probably going to be 80 or 90% of your whole LLM workloads. You're going to start with RAG pipelines. The pipelines that are designed to go to some data source, maybe vector database, maybe external website or anything, and gather information which is the most relevant to the user query, and return this information which, in a way that user or maybe other AI can comprehend and act on. From another side, you have type of the workloads which kind of doing the same. The only main difference is that now, instead of doing the return of the text to the user, you can actually perform some kind of arbitrary action based on a decision done by LLM on behalf of the user. It's as easy as that. You send email asking to cancel your order, well, and your order being canceled and account deleted. Well, be careful what you wish for when you work with LLM. See, looking deeper into RAG pipelines, and maybe in pretty much every paper which you're going to find about RAG pipelines, you will see they have like some distinctive steps. You always have parts that will be collecting and aggregating, normalizing, chunking data, embedding it into your vector store, maybe reshuffling it, clustering it. From another side, you'll have parts which are responsible essentially for retrieving that and pushing the answer to the user. But what is the most curious part about RAG pipelines, if you'll take a look how they're being displayed inside these papers and inside pretty much every article people wrote, they all have distinctive steps. They all have these blocks and arrows between them, which surprisingly look exactly what we need. It is simply data workflow and data passing. I'll be showing examples today in PHP, but I think I'll do that mostly for visual purposes. It can be easily done on any language you love. In Python, Node.js, Temporal allows you to switch stacks quite easily. But if you're going to implement the RAG pipeline, the very simplistic approach is most likely going to look like that. It doesn't require much thinking. It's just a number of steps. Some of the steps will be used in LLM, like to summarize queries. Some of the steps are going to be going to external source to find this information and push it back into a pipeline. They can span for many, many actions, have some branching or some additional conditions. The action pipelines, once again, they're not that much different from temporal perspective. The only major difference is that instead of giving the response back to user, you're trying to act based on this response. And temporal makes this approach quite simplistic because when you're trying to act, you're trying to execute something within your environment, and temporal already connects to all of your environment. So gluing that to your activities and calling one of your services is extremely simple. If you'll take a look at LLM activities, and this will become important in a lot of slides, you will also notice quite interesting pattern. Every time you're trying to make an LLM call, first step what you're going to do is to assemble the context that will be sent to LLM, or prompt as we call it. This context, in a simplistic terms, can be represented as simplistic template. You just have a number of variables, number of things you found in a knowledge base, something you found from the user, maybe on the internet, who knows. You put them all together, and you just send them, and then you just send them to AI. You wait for this response from AI, and then you interpret the result in some structured form. The first thing we noticed while doing pipelines like that and writing actions like that it is actually extremely important to validate the AI response within a single activity. You can, generally speaking, get the AI response, send it back to temporal, and then do the execution in different activity. But the problem is you can't actually trust AI. So what will start happening is that in some cases, your activity will be executed successfully, everything is okay, your activity is done, but the payload that's been generated is actually completely invalid, and your workload just stuck. You cannot execute next activity at all. So it does make sense to combine them in order to make sure that you never leave activity with invalid data generated by AI. So far, if you will take a look at these workflows, they don't possess any threat to any of the engineers. They're quite linear. In some cases, it's dark. In some cases, you can even describe them in some DSL language. But at the end of the day, they are just temporal workflows. So the only thing you do is you replace some actions inside this pipeline from normal activities to the activities that go to LLM, and it just works. There is no additional magic, and there is no additional things you have to do except for just assembling this workflow. The problem will start arising once you start making this workflow long enough and complex enough to start processing more and more information. Because modern day LLM models, they're quite hungry for tokens. And some models can comprehend up to 1 million tokens, which is a lot of pages of the text. So if your workloads will be growing and information going to be passing remember that temporal stores all the payloads that pass in and out your activities in temporal history. This will cause a very nasty problem later on because you will never have a very confidence that your workload won't die simply because some LLM decided to write a poem instead of giving you the correct action. Oh. So the way how we decide to solve it and how you can solve it, you have multiple options. Option number one is to don't do anything, just write smaller pipelines. And in many cases, when you're doing something very simplistic, it just works. You don't necessarily care, and you can always retry or maybe just ask AI to be a bit shorter. In other cases, you can be a bit smarter and try to use implicit data referencing, where you're going to implement your own data converter and your own interceptor layer that will be detecting that payload is larger than you want and offloading that to external data store to be used later. But what we found working the best for us, and that's the moment where I want to remember how prompts work, the moment we found work the best for us is to actually use explicit referencing. Because at the end of the day, all the information that you put to AI, all the information that AI is trying to act on, this information is actually only needed in a moment when you compile your prompt. You don't actually need any of this data or any of user PII inside your workflow. So don't do it all together. Just keep it outside and use the referencing using some links, some IDs, or database keys. This becomes handy when you're trying to assemble information from multiple systems, because by implementing universal referencing mechanism, you can actually combine information from multiple parts of your application and then just combine them all and resolve them all in a one distinctive place where you actually send information to AI. This way, your workflows will be completely free of any user information, and yet they will be used to orchestrate this process altogether. OK, so we have doc workflows, action workflows. We did the dereferencing. Probably nothing else we want to do. Users are happy, right? No. Users want not just to use a button where they click on something, expect something. They actually want to talk to AI, because that's how many of the users in the market perceive AI today. What you see in the picture is actually the GIF of one of the sessions we had with one of the agents, which, based on the user request, perform additional actions, run to some of the activities, and pull information in to give the correct answer. But implementation of these workflows might look similarly complex at start until you realize it's actually not that complex. Because the model of temporal allows you not only to write linear workflows that begin and end, but also the workflows in which you can implement such thing as a main loop. By making the main loop and running the LLM activity in it and populating this loop with information what the workflow receives using signals, you can implement quite sophisticated system that actually lives on a side with the user and answers his question in real time. At the same time, you do maintain whole state, and at the same time, you do maintain whole control of this process. You can see how much token LLM already consumed. You can see how fast it responds, and you can do the actions based on that. Implementation, once again, can be done in any language, but it can fit on a screen. It's not that large. Temporal makes it so easy because by exposing you to the code level, you can simply implement this loop like that, and voila, it just works. Also, by doing that, you're going to get a lot of benefits from composability model of temporal, which means from the user perspective, while users send the message and go the response back, it doesn't necessarily mean you have to do a single action by going to AI. You can do something else. Specifically, before this message is sent to AI, what you can do is enrich it with additional context. Replace this block with your RAG pipeline that connects to your knowledge source, let's say information about your product, and voila, you have customer support bot that now talks to you about your product specifically. If you're trying to do long conversations or conversations that span for days and months, or maybe it's an email thread, sooner or later you're going to enter a situation that your context of your agent will be overfilled and the agent won't be able to act. Once again, because you run all of this process inside temporal, inside main loop, it is exceptionally easy to detect this moment and see how much tokens AI consumed, and use this approach to actually offload the past conversations and restart the new LLM session with conversational history. In essence, all you do, you summarize the past messages, you put them back into the history or context or the prompt, and you run again. The user won't even notice. However, from agent perspective, he starts from a blank slate, just knowing something from the past